much for inviting me to hold this keynote. Um, I am mostly looking forward to the discussion, and we'll try to zoom through this as quickly as possible. My talk today is centered on OCR technology, which has been my personal frustration and my professional bread and butter for about 10 years or so. By way of a background, whilst doing my PhD, I started working on developing an OCR solution for historic Latin text as of 2016, with my co-founder to be Nick White, whom you see in the picture there. We ended up founding a small not-for-profit company called WeScribe, where we would take on paid commissions in order to develop open source OCR solutions specifically for historic text. As it might be hard to imagine at this point, OCR was a very, very different beast back then. And so what I was hoping to do today is give a quick overview over the developments of the past 10 years, how that made us think about quality control, what kind of mechanisms we use to to improve our models as also our output, and what that holds in store, in my opinion, in general, about how we view the importance of accuracy, errors, mitigation processes, and how all of these moving targets change with the advance of technology. So, forgive me the bad joke, but I thought it might make sense to equate the different eras of OCR, so to speak, with Showa, Heisei, and Reiwa, insofar as for a long, long time before the entry of neural networks, OCR was really a technology that yielded something that, in the best of cases, produced output that was better than nothing, but just about. So until not too long ago, I would say in the case of the Google-powered open source OCR software Tesseract, until 2018 even, a lot of openly available OCR mechanisms were based on rules rather than networks. And most of them were also trained with synthetically created ground truth. This meant that unlike many OCR softwares today, they were kind of trapped in the Platonic cave, as it were. They were trained on ideal type digital fonts. A lot of the error mitigation, so to speak, was done in post-processing, where output was corrected with the help of dictionaries and language models. And our main source of control, the so-called confidence score, was based on the classification of each character in the OCR output. Now, with so-called Heisei, if you allow me the joke, as of some 7-8 years ago, neural networks have become quite standard in OCR processing, and that has effectuated a complete paradigm shift when it comes to OCR processing. The quality of the output has jumped by levels unimaginable before. And I believe this is partly due to letting go, but also moving forward. On one hand, the letting go part refers to letting go of strict quality control with the help of dictionaries or like quite sort of rigid language models. And instead, the OCR itself takes most of its cues with regard to language from the material that it is actually trained on. Then a second big game changer was the so-called LSTM introduced in these neural network-based OCR technologies. LSTM, it sounds somewhat contradictory, but it is short for long short-term memory, and very briefly explained. Now OCR not only assessed the text in a digitized page, character by character, but at least in the case of alphabetic text, or text written in the alphabet, now each character was classified with the help of the surrounding content. So in that sense, not only the accuracy became a lot higher suddenly, but also the validity of the confidence score produced with it improved radically. Now, The third topic I would like to touch upon ever so briefly is the age of generative AI, which is not something I have ample experience with, but I believe this is something that is on all of our minds, and if possible, I would like to open a discussion at the very end of this talk. Now, moving on. When aforementioned Nick and I started working with Tesseract in 2016, as I said, the world was really quite different. The OCR we were working with was rule-based and quite rigid in many respects. However, we had set out to develop an OCR specifically for Latin historic texts. And so, particularly in our testing phase, when we were really trying to develop a workable solution that was just a little bit better than nothing, we made a lot of use of the so-called confidence score in order to assess the output we produced. Now, specifically for OCR, you always face sort of the crux that assessing your output, if you really had the perfect measure for understanding your output, you'd be measuring it in accuracy. In order to assess the accuracy of OCR output, however, you need a text transcription of 100% accuracy. Now, if you already had a transcription of 100% accuracy, you would not need OCR. So in the meantime, to save you the time from going through every single page and counting errors, the confidence score, which is produced by the OCR engine, can help you as a proxy for roughly understanding the probability that your output has a sufficient quality. So to reiterate, the confidence score, which is produced by the OCR engine alongside the text output, typically comes as a percentage that describes the probability that the output is correct. It is not the same as accuracy. It is assumed to be proportional with accuracy. But as we can see, for example, in this particular example here, this is a so-called HOCR file, which maps the confidence for each word transcribed in the text file on the right. So if I may draw your attention particularly to the words imperfectia and continuatur, you see that the second one is correctly transcribed, but at a significantly lower confidence, namely only 11, than imperfectior. No, imperfectior transcribed as impersectior, confidently but badly transcribed. So to reiterate, accuracy and confidence do not always reliably relate to each other. But if we look at it at scale, and if we keep the sort of relativity of confidence as a measure in mind, it can prove quite useful in assessing the output. Now, the second caveat is that confidence as a relative metric, it doesn't compare so well across OCR engines. So really, you have to be aware of the context that you're using it in, because it might not translate beyond. This is an example where we compare the confidence of two different OCR engines for the same book. The graph that you see in the picture maps the average word confidence for each page in a book. And as you can see, the purple and the blue is vastly different. It actually turned out that the accuracy, when we actually went to manually counting errors, wasn't so different. It's just that either OCR engine had a very different idea of how well it did. Now, moving on, going forward, I will mostly be looking at Tesseract produced output. So what we're looking at here right now, we're our first attempt at visualizing confidence scores in different ways in order to aid our analysis of the quality of the output we produced. Again, at the time, we were working with historic Latin printed text. So from the 16th to 18th century, just about. A lot of the pages were discolored or warped, had like interesting fonts. And so these were our main challenges, really. We started by creating these heat maps where the higher the confidence score would be, the greener the word, the greener the label, so to speak. So this actually allowed us to, when we were OCRing a whole book, to quickly flip through these pages and just by looking at the colors, seeing pages that went egregiously wrong. if we saw a page that was largely green, we would probably skip it and then move on to something that was very red and orange to see whether we could identify a systematic error that had to do with something we could feasibly fix by training a better model or changing other parameters of our process. In the case of these particular pages here, you see that the page on the left, like you always have to go back to the original image, unfortunately. There's no way abstracting the process to the point of absolute analysis. So what we see here, if we compare the good page with the original page image, it is a relatively regular font. But the page on the right side was all written in cursive. And so what we then decided to do is retrain our model with more and more cursive material until we realized really the problem of cursive had to do with binarization. If you look closely at the text here, the little red boxes tell you how Tesseract segmented the single letters in the page. And cursive is much more, has a much higher danger of being broken by aggressive binarization thresholds. Just by quick way of explanation, prior to OCR it is still customary to pre-process a page into a black and white assemblage of itself. You can do this at different levels of aggressiveness. Ideally, you remove all the discolorations, but you have to be careful not to break the letters. So basically, we were using the confidence score a lot in order to find out the perfect threshold that we should use for binarization for optimum OCR processing. On the other hand, this kind of heat mapping and sort of detailed analysis of the segmentation and also allowed us to look at sort of more detailed mistakes. And quite often, to be honest, we would come across errors that we probably could have fixed manually, but didn't, simply because we didn't have enough time on hands, or we didn't have enough hands on our hands, honestly. And when it comes to these small details, the true scholar would probably hone in and make things right. Whereas the digital practitioners that we were, if we couldn't identify something as a systematic error or something that we could actionably fix, we would quite simply skip the matter. That was somewhat upsetting in the age of rule-based OCR, when we were mostly working with librarians who have a very similar, very different idea of accuracy. For most of the people we were working with at the time, anything less than 99% wasn't really useful. We considered our 90% accuracy OCR at the time with our shovel and bucket system quite a success. We thought it was useful for keyword searching, perhaps even for slightly more complicated applications, but for the librarians, that was simply a no-go. And so at the time, it was hard to find takers for this kind of technology, which is how it's something that radically changed with the entry of neural networks into the system. As I explained previously, the technology with neural networks significantly changed, and the biggest game changer was that now you could train the OCR models with genuine ground truth created from actual materials. So that was the way out of the Platonic cave, where the model had to make inferences from ideal types onto the real world. And now you could actually present the real world to the model, from which it then made inferences onto other examples from the real world. As you might be able to see in this particular example here, the change in the error rate was radical. And ironically enough, this actually caused that to look less and less at the page. Our analysis actually went further up a level, where we started trusting the engine enough to not bother with the heat maps anymore, but then started assessing output simply by a page level. And so there's a couple of things that we then discovered that could be systematically improved. For once, whilst previous OCR was mostly based on languages, with the new neural network-based OCR, it was actually more beneficial sometimes to also focus on specific fonts, so script types. That might seem like a total plainly obvious fact to us now, at the time it was not. And I think it also had to do with the fact that a lot of the post-processing in the pre-neural network OCR world happened with the help of language models. Now that the post-processing wasn't so much of a problem anymore, thanks to the radical improvement of the accuracy in the OCR, you could also change the parameters of the models themselves. And so for many historic books that we started working on, models trained on different languages within a certain font family actually performed better than bespoke language-focused models, as it were. Yeah, so basically, this is how we kind of employ the confidence score then to kind of figure out systemic changes we could make that would not only refer just to like a particular language, but also inform our strategies about OCR in general. So as it were, we just worked on improving the size and the diversity of our ground truth pools rather than sharpening the parameters that define them in the beginning. Now, the other thing that happened is that the sort of science that we started working with started to be of a different kind. And I think this is really the result of OCR becoming so good that you could do many more interesting things with it. When at the time, the sort of like pre-2018, say, the output wasn't really reliable enough to do interesting analysis with it. Now that you could process corpora at scale and the output was 95% accuracy or more, people started becoming more interested in like large-scale text mining or topic modeling and things like that. The clients we were working for then, however, so basically because they were doing text mining, one thing we then also increasingly focused on was not just producing good output, but also cutting out stuff that shouldn't be in there in the first place. And for that, the confidence score was actually quite useful. So we started producing all these graphs to identify across all pages of the book the single pages that were problematic. So as you can see in this particular graph, for example, all the relatively high scores are relatively well-processed pages. And then you see suddenly a drop. And then when you actually go back to the original book, you realize this is just a page with nothing on it that's been mistaken for text by the OCR engine. So the confidence scoring system made it very easy to get rid of these sections that you didn't want to be in the output in the first place. And then some graphs obviously turned out more difficult. As I said, confidence is a relative metric. So whilst you have certain areas in this graph processed at the same level of confidence, they probably have roughly the same level of accuracy. But then you see little dips, you see little sections at regularly different levels of confidence. And so once we started looking into those, it turned out that those were reliably sections that either contained a whole bunch of pages with indices or mathematical formula or different language content. So in a way, so whilst in our project, we actually used the confidence score to cut out these sections, they also helped us identifying interesting content that we then looked at later for different reasons, basically. Now, the last era that we're currently entering, as I said, is the world of generative AI, which works along very different parameters. I believe for most of us, it is still true that we are still experimenting with this technology as it is mostly trained and provided by third parties rather than training OCR models ourselves and having some control over this process. Now, in a somewhat graceless experiment, I tried it this morning to OCR a manuscript page with ChatGPT, and actually was quite surprised that the output looked like genuine OCR output insofar as it was so bad. It was clearly very helpless with what it was facing, even though it very gracefully dealt with the layout. Now, as we know, the world of generative AI is the art of improving prompts. So the second time I actually asked it to improve a little bit on this, it produced a text that actually looked very reasonable. And obviously I was very pleased with this. But then if you look at it more closely, you actually see that hardly any of the text, in fact, every word that is in red has nothing to do with what's actually on the page. And now, what I find very interesting for us going forwards as digital humanities scholars is how to get from here to here without putting in exactly the type of work that OCR is supposed to avoid for you, namely transcribing it all yourself. I think, as we all might agree, one problem about generative AI is the mode of presentation. It looks very smooth, it looks very plausible. And so whether we're actually looking at good content or not is hard to establish until you engage with it directly. But on the other hand, I believe it holds great promise, particularly when it comes to layout analysis. It's just that somehow, I think if we want to collectively work on this, it probably takes people with a niche interest taking the matter into their own hands and training technologies such as that for specific purposes. Now, very quickly, this has nothing to do really with OCR, but this is just a general observation that I think is worth keeping in mind. With the very basic observation that mistakes do matter, particularly in OCR, they should not get lost. They help us understand the transmission of text. They help us understand the communication between human beings. And well, this particular page is perhaps my favorite example to date. It's the story of the Frankenfish, which from a 15th century translation, painstakingly done by Theodorus of Gaza in the 15th century, was the Sargiacus, as you can see, was morphed in the Sargiacus, which is a fish that doesn't exist, but survived in this very semblance into the 19th century, at which point nobody could tell where this fish had come from in the first place. Definiri non potest. So what I would like to say with a view to generative AI, and then before I open the discussion, is quite simply, if a lot of the output is mediated by the plausibility or the probability, as inferred from unrelated contexts, how do we retain the errors, like all the little mistakes in history that are important to our scholarship, or differently said, how can we harness this technology to improve the accuracy of our digitized output without letting it smooth over the irregularities of human history? And with that question, I would really like to open the floor, and I would very welcome any questions from all of you. Pardon me this slide. Thank you very much.